as Susanna was saying, I have been doing this microservices thing for a while. Most recently, I've been at Meetup, which is a company owned by WeWork. You might have heard of them. You might have been to a Meetup. It turns out that I need to know you can update. Last Friday was my last day at Meetup. So if I say anything here that sounds weird, it does not represent Meetup at all. So don't blame them. Blame me, maybe, I don't know. But one interesting thing, back to, again, Susanna was saying about how back at SoundCloud, I spent many years there, and prior to that, I was at ThoughtWorks for a few years, how I've been a few times going through this kind of microservices transition, which it really is going from monolith to microservice architecture. Most recently, when I actually joined Meetup, I faced a new kind of paradigm that some of you might be familiar with, which is all this serverless stuff. I feel like I'm I used the word traditional microservices the other day on Twitter, and people made fun of me, and they should. But like, I feel I'm a very traditional person when it comes to service-oriented architectures. And this was a great opportunity for me to check my biases, which are based on experience. Experience and bias is really like the same thing at this stage. But work out what's the new kind of way, or a new way, to build microservices with some of these things that people usually call serverless. Now, the first thing I want to do is to kind of create a shared vocabulary here. I won't spend too much time on this, but I found it to be important in other talks I've given, which is try to create a working definition of what's a microservice and hopefully other words we might need. The first one is, what's a microservice, or what are microservices? The interesting thing I found about software engineering in my career is that most things have no actual definition. We reverse engineer some form of definition from what other people have done. So over time, at QCons and many other conferences, people have come and say, hey, at Netflix, SoundCloud, Twitter, whatever, we've been trying this kind of stuff, and it works. And somebody's like, oh, I'm going to call it microservice. Like, dude, you call it whatever you want. It works. That's what matters, right? So we kind of were able to reverse engineer the definition based on a few things that are shared by these companies that have been applying this kind of technology. It's very similar to how Agile came to be a word, right? How these folks got together, like we're trying to do all these different things. It seems to be working. Let's see what's common amongst them all and give it a name. The way I like to refer to microservices is that they seem to be highly distributed application architecture. Now, there are a few interesting words here. Highly distributed is one of them. By that, I mean that you don't have one or a few big processes, software systems running. You have actually a boatload of them. You have many, many different processes that implement various different many different software systems that implement business systems you might have. This seems to be something common across all these different use cases we might have seen. Something interesting is that I say distributed application architectures because I'm sure you've been to many talks at this conference and others and articles and whatnot where people keep talking about distributed systems, which is something everybody's talking about all the time and gets really boring, to be honest. The main difference I see between what I'm talking about here and what usually is called a distributed system is that these people often talk about infrastructure pieces. So they often talk about databases, consensus, gossip, things like this. All this stuff that nobody really understands, but you need to pretend to understand so you get a job at Google. So that's not what I'm talking about. What I'm talking about is actual business logic pieces talking to other business logic pieces. That should be, hopefully, a good enough definition for what we want to do now. Now, moving on, another one is, OK, so what is serverless? So that's an interesting one because, like I said, I'm not really that experienced in this world. There's many people in this very room right now who have been doing this for way longer than me. I'm a biased, traditional person on the microservices side of things. So my answer to this is like, dude, who knows? Like, I don't know what's serverless. It seems like every single person has a different definition, and it's weird, and it seems to be really whatever a cloud provider wants to do. It's one interesting difference I found between what's generally known as serverless and what became the concepts behind microservices is that the microservices realm seemed to be, again, reverse engineered from practitioners, from people coming to stages like this, writing papers, writing blog posts, say, hey, we've actually done this. This is how we managed to get Twitter out of whatever it was back to sanity and no failoways or whatever it is. Or we've done these things at Netflix, and we're able to deliver all this stuff. Serverless seems to be the other way around. There's a lot of cloud vendors pushing new technologies they want us all to use and giving it a name and kind of packaging it in a nice format. There's no problem with that. I used to work for a cloud provider. I know how this market works a little bit. But it's different. And I don't know if I'm qualified to give you a definition, so I'm going to actually rely on a definition by a couple of smart people who are based in New York, Mike Roberts and John Chapin. They run a company called Symphonia here. Full disclosure, I'm friends with them, but also I've hired them many times to do various forms of consulting work. You should totally hire them. But very conveniently, they wrote a book called What is Serverless? That's good. There's some definition there. There's like some kind of litmus test, which I like. But we don't need to go too much into detail to talk about to tell the tale I'm going to talk to you about. So maybe the most interesting definition or part of this definition is that there's a disconnect between what you work with, the code you work with, and the concept of servers, hence serverless. There's a few ways that it manifests itself, but one of them is that you don't really think about CPU or memory or instance size or instance type, things that you might have to do with containers or VMs or things like this. So I'll go with this. This is good enough. Go check the book. It's actually available freely online. But then some examples of what this is come to probably a few things. Up to yesterday, this slide only had 3 logos. The first one on the left is Amazon's Lambda. Then there's Google Cloud Functions. I actually never used that. And the other one is Microsoft Azure Functions, I guess they're called. So I also never used that. I've only used the AWS flavor. I was here at the conference yesterday talking to some folks, and they were mentioning that they actually using this kubeless framework or platform, whatever it is, that allows for you to build serverless on top of Kubernetes. Never used that, just found it interesting. Go check it out. I will check it out as I have time during the week. But those are some of the flavors of what's generally known as serverless frameworks, platforms, whatever you might want. Now, trying to tie it back to the story I'm trying to tell you all here, there's a general piece of advice you receive all the time, which is try to keep your monolith for as long as possible. Most people will tell you, hey, if you start a new company, or if you start a new kind of initiative within a bigger company, whatever it is, don't try to just spread out your system through many different microservices, and I'll get all this RPC going on. Should we use this? Should we use gRPC, HTTP, service mesh, whatever? This is probably not the right time for your company to be thinking about this. Instead, what you could be thinking about is how, to grow your business. You don't know if you're going to have a company or this initiative within your company in 2 months' time. So don't focus too much on the technology. Focus on the business, and just keep things on a monolith. And usually, this advice is paired with something like, OK, but by the time you need to move away from the monolith, usually what you do is that you have a big piece of code with many various different concerns represented by different colors there, and you start splitting one over there and one over there, and slowly moving things away from the monolith. Now, my experience is that you're actually never going to move things away or extract them from the monolith. The code's still going to be there. You just pretend it's not there. And it's often OK. So if you think about, like, Twitter only turned off their monolith a few years ago. SoundCloud still uses the monolith, and I left that company 5 years ago, and we were kind of way into the microservice journey. So don't worry too much about it. But that's kind of the general framework people use when extracting systems. Now, one interesting thing is that what happens if you follow this advice so well that it took you 10, 15 years to actually consider moving away from the monolith? Now, something that has happened is that, as I was saying, all this stuff like serverless and various other options came to become a thing. And this wasn't available when I was first doing migrations from monoliths to microservices at SoundCloud back in 2011, 2012. But they're available now. And this is a little bit of the situation Meetup found itself in. At Meetup, Meetup is a very old company. I didn't know that before joining. It's kind of 16+ years old. It's one of the kind of original New York City startups. And it's mostly based on one big monolithic application that, for various reasons that are not actually funny, we call Chapstick. Chapstick is a big blob of Java, actually Java the platform, because there's also Jython, there's also Scala, there's probably some stuff that I never really cared to look at. It's just your regular monolith developed over many, many years. It's not the worst thing I've seen, but obviously it's very hard to work with. So engineers at Meetup have decided that at some point they wanted to move away from it. They tried different things. That was way before I joined, so I didn't so much actually know about this firsthand. They tried moving to your typical microservices setup with containers. There was an attempt at using Kubernetes locally, various different attempts, and they all kind of failed for various different reasons that, again, having had some experience with this, I think a lot of it had to do with trying to go from the monolith straight to Kubernetes. And there are other ways to get there. But anyway, the point is that there was a big problem. We had this monolith. The company had just been acquired by WeWork. Meetup was acquired by WeWork, I believe, in 2017, I want to say. And we knew change was coming, and we need to get ready for that. So what does that mean? One engineering team in particular was really passionate about this new flavor of things, what we usually call serverless. And they decided to give it a shot and built a few projects that looked a little bit like this. So this is actually a screen grab from one architecture document we had. And it might be a little confusing to explain if you are not used to kind of serverless asynchronous architecture, but I'll try my best. The first thing far on the left-hand side, on your left-hand side, is Chapstick, our monolith. Chapstick, again, Java code right into MySQL database. Now, one thing we've done is that we followed a pattern that was mostly popularized by LinkedIn, to my knowledge, with their database project, where one interesting thing about some of these databases, like MySQL, is that whenever you have a master replica set up, there's something called the bin log. The bin log is the way that a master, so where you send your writes to, tells all the replica that are read-only about some change that has happened. So the bin log contains every state change within MySQL setup. So all inserts, deletes, updates, whatever, it's part of the bin log. One thing that, again, companies like LinkedIn have done in the past, and we've done at Meetup, was to actually tap into this bin log, this stream of data, and try to convert this into events. So every time a user was added to the user table, there was some code that would read from the bin log and create a user was created event, and then serialize that into a DynamoDB table. So DynamoDB is a database by AWS. It's kind of one of the original NoSQL databases. It's very good in my experience, but don't worry too much about it. Just know that it can hold a lot of data, way more than any typical MySQL or Postgres setup. Anyway, we keep pushing all this stuff into DynamoDB as events. User was added, user was deleted, user joined group, user left group, things like that. And then we had a lot of other Lambda functions that would consume from this database using something that's called DynamoDB streams, which is actually very similar to the bin log, where DynamoDB forever insert, delete, sends this as a message. This user was deleted, this row was deleted, this row was added, that can be consumed by other systems. We would get another Lambda consuming this information and actually doing some processing with it and copy it to a different database that would be a very specialized version of what we wanted. In this particular case here, this is kind of the architecture that used to show the members who belong to a group. So if you go to Meetup right now, /groups, /whatever, /members, and you see the list of people who belong to that group, could be the New York Tech Group, for example, is a big one that we have in New York City. This data comes directly from a database that's specialized for that. It went through all this processing to generate this kind of materialized view that serves that experience only. And that was the general design we had for a while. One thing that happened is that this project wasn't particularly successful. We're going to discuss some of the issues that made it not successful, but generally, we actually had to revert on this approach recently and went back to just have an API talking to the legacy code base. But I want to discuss a few of the challenges we had, and some of them are more interested than others in the long term for Meetup. Because there's always some accidental things. Like it's an old code base, it's an old problem. The team is formed by members who might or might not have some experience with this or that. But some things are probably general enough that we can extrapolate from them a little bit more. So some of the challenges we faced was, first, solving a bug means reprocessing all the data. Now, that's interesting. I probably need to go back to this slide to so that you all can visualize this a little bit better. Now, remember that I said the legacy code base writes to MySQL. And then MySQL says, hey, there was an insert on this table. There was a delete on that table back to this stream that is converted into events. So there's a user inserted event, user deleted event, all this kind of stuff. And then another system gets these events and say, oh, a user has joined a group. So when I'm creating my materialized view of all users who belong to a group, I need to add or remove that person depending on what goes on. One challenge is that all this is code we wrote. And as every single piece of code we wrote, there's plenty of bugs. Every now and then, we would find something, and one piece of this transformation wasn't working very well. We would patch it. That's great. But as opposed to online systems you might have, that also meant that we had to run all the data again through this pipeline. Because the copy we had here, so the database left to my right-hand side here, was not correct anymore, because we had fixed some logic or we had changed something. So that has happened a lot during this project. Every now and then, we would have to go and find out that, oh, actually, we thought that this field in the legacy schema meant this, actually means that. We need to remove that. Or, oh, my God, we cannot add accounts that were disabled automatically by the system. So we have a lot of spammers in the platform, as everybody has. We need to make sure they're not there anymore. We add the logic to prevent spam. We have to run all the data pipeline again. That was a little complicated. There's a few ways to deal with this in kind of event sourcing, CQRS architectures, but we struggle with this a lot. Another one is kind of the right path issue as I call it, which is I'm showing you the read path, right? I'm showing you how information gets into the screen that shows you who belongs to this group. I'm not showing you what happens when you would maybe add admin for a group and say, actually, I want to ban this person from my group. We've struggled with this a lot, because that pretty much meant that we have to rewrite all the logic that was in the legacy code. And ultimately, the pragmatic decision was just, you know what, let's just write back to just use the legacy code as an API for writes. And now you're like, OK, but then why did we go through all this work just to get the read path if the write path is actually going to the legacy code base anyway? Are we any more decoupled from what we had? Those are the questions we had, and these were the challenges we were facing. Another one, which is a little more common, is that we actually were using Scala. Meetup was heavily a Scala shop. And we had this issue of code start for JVM Lambdas. Now, code start is what happens when the first request hit a Lambda that you just deployed. Amazon, in all its magic, needs to get your code from some form of disk, load into memory. And if you've worked with the JVM for a while, you know that JVM also does a lot of optimizations in itself. So it takes a few, I don't know, depends on what could be milliseconds for that particular function to be up and running. If it's steadily receiving traffic, that's fine. But for the first request, it's always a little challenging. We had a lot of problems with JVM Lambdas based on this. And this is one of the reasons that we migrated some of our JVM Lambdas to use Amazon Fargate, which is actually a container platform. So we had all these complications where some things were Lambdas, some things were containers. It was a bit crazy. Another one was DynamoDB costs. So DynamoDB is an interesting one because, as you remember, probably, hopefully, from 2 slides ago, we had a lot of copies of the same data. So we were paying over and over again the price for storing the same actual data. There was no one canonical model we all used. We had different specialized copies from it. DynamoDB is interesting in the sense that, well, very similar to anything else on Amazon, it's mostly, by default, you do on-demand provisioning. So, hey, I want a new table. Here's a new table. I actually don't need this table anymore. OK, it's fine. Don't worry about that. It turns out that if you ever had to deal with Amazon billing, this is kind of the most expensive thing you can do. It could be OK for your use case. It's OK for a lot of people. But in our case, this was extremely expensive. And the solution was really to do some good old capacity planning and sit down and work out, actually, we need this much data. We need that much data. We literally, like the Symphonia guys I was talking about before helped us with this. We literally saved millions of dollars just by actually working out, we actually need this data. So, hey, Amazon, can we provision this beforehand as opposed to just asking for it on demand? But to me, as the person who was kind of overseeing architecture developer tools team, the biggest problem was that we had no governance whatsoever. It's like, who's calling what functions deploy where? The moment when you go on your Amazon console and you list all functions and you see people names as a function name, you know you're in trouble. Like, there's absolutely no way to know what's going on. To this day, some functions, we turned off some functions that had VP's name, and turns out it was actually very important for billing. We did not know. Nobody knows. Like, she wrote that many years ago. I don't know. So anyway, it was a little hard to manage all this stuff. But again, thinking about me coming as this very biased microservice, old school, Jesus, I can't believe I'm saying that, person, I walk into this scenario and like, OK, this is, I could see this was going to happen. You know, told you so, told you so, told you so. But there were a few things that I 100% thought was going to happen and didn't. One of them is that getting new engineers productive on Lambda and DynamoDB was actually pretty easy. And there's something on top of this, which is we had hired a lot of new engineers from Node.js front-end backgrounds. All this stuff was in Scala. So one thing I found out is that, well, first, I've used Scala for a fair chunk, and I know that Scala is the kind of language that either you hate it or you love it. There's no middle ground. Nobody's lukewarm in Scala. I happen to like it, but I know very well. I managed 200 people writing Scala and swearing at me for a very long time. But the interesting thing is that if you're actually writing just maybe 200 lines of Scala or 300 lines of Scala, it's not that hard, especially if you use things like IntelliJ that really help you out. The way I think about this is the same way as I personally deal with makefiles. I've been in this industry for 16 years. I don't know how to write makefiles. I have never learned. I copy, paste, change, and move on. It's probably like there's been one makefile that somebody gave me, and I keep changing these things for 16 years now. I actually have no idea what I'm doing, but it works. It's fine. And that's kind of the approach that we were taking there. Obviously, we had tests and some kind of different support to make sure people are not doing something completely stupid, as opposed to what I do when I make files. But that was kind of the principle. It's very discoverable. You can just change something and move on. Another one is that because I was talking about code start, I mentioned that we moved some of the things to Fargate. Then we kind of moved them back to Lambdas, but we converted them to Node.js Lambdas. And we didn't find any of the code start problems anymore. Obviously, there was a little bit of an issue, but nothing that would hit us to the level that the JVM ones were sitting. Another one is operations allergy. So I have, again, I spent 4 years at ThoughtWorks, so I'm very kind of doctrinated into the right way of doing things. As any ThoughtWorker would tell you, there's only one way, it's the ThoughtWorks way. And one of the things we were super big on is the DevOps culture, which is different from having a DevOps team. Just parallel, if you have a DevOps team, you actually don't have DevOps, but that's a different conversation. Get me a beer and I will rant to you about this. The thing here is that I'm so used to building engineering teams and trying to get people to own and operate their own systems. And they've been really, really allergic to this. They really actually hate it. I was just like, this is exactly the same thing that's going to happen here. It turns out that although Lambdas can be really weird at times and opaque, it doesn't really happen that much. In my experience, people are reasonably happy being on call and just operating their own system. I think it has to do with the size of things. If I'm responsible for something that even as a microservice, it's kind of big, and I don't know everything that's going on there, because I might be more of a front-end person versus a back-end person, it's complicated. If it's something that's using the language I'm used to, and I have all this tooling, and it's small, it might be OK. Anyway, another one that was 100% sure is going to happen is local development. So how do you, everything's on the cloud. How do you do local development on your machine? If you take a plane? Turns out most planes these days have Wi-Fi, at least in the US. So that's not so much of a problem. Just get a company to pay for it. It's easy, of course, sure. But one interesting thing about local development is that most of the tooling we have available right now, my only experience is with, like firsthand, is with the SAM framework from Amazon. Have enough simulators that you can use within your local development. But I don't actually suggest you do much with them. One thing we've done at Meetup is to make it really easy for people to provision their own accounts. So they can have a sandbox space where they can deploy all the Lambdas, do all this stuff without messing with other people's in production systems and things like this. The simulator reminds me a lot of Google App Engine when it first came. it's just like, it works 80% of the time, but that 20% is what's going to kill you. So the last one is really developer happiness. I thought that people would, this would make no difference because it's just like back-end technology. Most of the engineers don't care about that. They want to develop a product. But it turns out that people are really happy with this whole stuff. They really wanted to keep using that. And it's not just because it's different from what we had as a legacy system, because they could use something else. They could use containers. They could use whatever they wanted, really. But they actually wanted to keep using that, and they were asking for more help and tooling and training on this. So the one question that then came to my mind, and I was working with my team on, was like, how can we keep the good and get rid of the bad? Because, again, I was coming in super biased. I had all my years of microservices. I've done, the SoundCloud position. Then I worked for DigitalOcean, went to the same stuff. I worked for a service mesh company for a while. So I have my opinions about how things should be done. But it was pretty clear to me that lots of this tooling, which is good, exactly, it works. It's not perfect, but it works. I was thinking about this for a while, and I realized that maybe the easiest way for me to rationalize this whole thing is not too dissimilar from the same way that I perceive that we went on through microservices and other things, which is, if you think about it, many years ago, if you've been in this industry for a while, you usually have a few applications within a company, right? So in this silly example, you have the financial reporting application, you have some form of user manager application, and some kind of point-of-sale application. They're all different, they're all independent. They might be because, if you're talking about old school, they might be managed by the same team, but it could be completely different. Maybe it's even different consulting companies writing them. So this was a picture that anybody would show you on the first day working for any corporation, maybe 10, 15 years ago. What they didn't tell you is that actually it was kind of like this. So, the back end of it's one company. Everybody needs the user data. Everybody needs the sales information, whatever it is. There's always some kind of cross-pollination, if you will, or collaboration is probably a good one, across these different databases. And we have perceived that this was a little bit of a problem because, all these systems would couple into each other. They rely on the schema information and various other things. One way we managed to get out of this kind of mess was by creating what's kind of known as services. So the way I see this is that we have the service-oriented architecture is a very old term in technology now. We've been talking about this since like the late 90s. And it means different things for different people, but mostly it means that you expose this kind of feature and data that you need to other systems on your network. And one thing that I've seen happening a lot is that once you did that, you didn't really have this kind of whole application or like independent applications that had their own backend and their own data. You started having, you might have been to projects like this. I'm sure if you were in the industry 10 years ago, you worked in some sort of customer portal or admin portal, because we're kind of tying all these things together. Instead of having one application to do this little thing and the other application to do this other thing, we actually were having one front end that would talk to many different services in the back. And this was kind of how the industry was evolving. And this was generally interesting and good. Now, one interesting challenge or one interesting way that I see serverless applying to this whole picture is that even if with microservices we would have smaller of these boxes and smaller services, we still have only so many ones. Whereas what serverless tend to do is something more like this, where actually you start exploding your features into 1 million different functions. And again, these functions are 100 line of code, 200 line of code, and it's very easy to make a function talk to each other. It's very easy for these kind of super deep in your system features just access data from another super deep in some other system feature. The systems don't really exist anymore. The red lines or the colored lines there are just to illustrate how these things are kind of related, but not really. And that's a little bit of what we ended up at Meetup. And it's funny because a few months ago, I was on Twitter, where else, and I saw somebody describing this, I think, perfectly, which is a guy I used to work with. He's still at Talks called Chris Ford. It's kind of a whole paragraph, but pretty much he calls this the pinball machine architecture, where you send a piece of data here, and there's a Lambda there, Lambda there, Lambda there, Lambda there, sends to a bucket, put it over there. You don't know what's going on anymore. And this is pretty much what we had. As we progress towards this kind of architecture from something more like this, we just don't know what's talking to what's going on. So we were legit victims of this, pinball machine architecture syndrome, if you will. I don't know if that's how Chris would call it. So thinking about this for a little while, it's like, okay, here's the challenge we have. We want to keep the good things about serverless architectures we talked about. We had good provisioning systems. People are generally happy to write code for it. We have good support, have good tooling. We have all this stuff. What are the things that we need to do that will prevent us from getting to this kind of pinball machine architecture I was talking about? Well, the first thing is that I think like every presentation I've ever given always falls back to something that Martin Fowler has written before. And if you haven't worked with me, you're going to receive a copy of this PDF at some point, because it's kind of one of my favorite articles in software engineering of all times, and I think it's super underrated. So this is a piece Martin wrote, I don't even know when, it was many years ago, about the difference between published and public interfaces. Now, the article is good, read it, you will understand it. He has very good examples. But mostly think about it this way. Any programming language, I don't know if any programming language, most programming languages will offer you some keywords like public and private. Java has that. Go has some convention system. It goes about this. C#, Ruby. Like either there's a keyword or some kind of convention. And the interesting thing is that, for example, if you talk about Java or Ruby, you can go into the runtime library for these languages, and you can find this class deep in God knows where, in some kind of weird package you never heard about, and you can access it. You can access it because what public and private in a programming language do doesn't really have to do with security. It doesn't have to. It's a different level of access control. Even in programming languages like C++ and others that have package protected things, you can always find a way to access this stuff. The point is that, OK, semantically, they could be expressed in a better way, but it doesn't actually matter. Because what matters is that the person who is providing you with the library or whatever it is needs to offer you some published interface. A published interface is what you want your users to actually use, what you want them to be able to, what you're willing to support them using to do whatever they want to do. It's not because something's public in a library that you might be using that you're allowed to use it. Of course, you can use it, and sometimes it's a very good hack. It allows you to do many different things. But it's not what you should be doing. What you should be doing is using what Martin calls the published interface, which is what users, or what the library owner or the service provider, whatever, provides you as an API. So I was reading this a little bit and thinking about all the challenges we're having. We found one interesting way to map this concept to our kind of explosion of Lambdas everywhere. So as you remember, we had this situation where we had lots of Lambdas, talking to a lot of Lambdas. This doesn't even do justice to the kind of stuff we had, because we had no idea what was calling what. And obviously, yeah, you can use this Amazon whatever tool, that Amazon whatever, but as you're writing code, you don't know. It needs to be a report that somebody generates. One thing we've done was actually to split them out and put some kind of API gateway in front of it. Now that's interesting, because this is, at the same time, there's a lot of contention and no contention at all about this design. It's actually recommended by many people that you always use an API gateway fronting your Lambdas. But at the same time, people look at this like, OK, but then aren't you just creating services and using Lambdas as your compute units? But isn't that just like the same? And to be honest, yeah, it's very similar. Again, I'm coming from my bias, so I'm trying to adapt this to keep what I seen working and throwing some things to fix things I haven't seen working. But it works well. And the thing here is that even though each one of these Lambdas is addressable, it can be called by anybody. You can prevent this with some security configurations, but we didn't even have to do that. Everybody in the company knows that the only way to access one of these Lambdas is through the API gateway. The API gateway is your typical HTTP interface. It has a well-known domain name that you access and do things. But that's the only way to go from A to B. So instead of having this kind of peer-to-peer communication network, you start piling things through the API. Us, it's the case since forever, since we began doing services. One interesting thing is that some of the internal Lambda functions in this diagram, and that's on purpose, call other services, and they can call it directly. You don't need to have like a boundary object that some people kind of create to make these calls. It's fine if they actually call the API gateway from another service directly. But this is something that we've done. So back, what we've done was really to start using serverless as building blocks for the microservices we had. It's really using the platform as a service part of what serverless provides, and not so much some of the more interesting bells and whistles that we could be using. One interesting challenge is that how do you segment, how do you create these lines across services? One thing we've done at Meetup is that we start using AWS accounts for that, which works well, except there's one big caveat, which is AWS is really bad at deleting accounts. You make a request to delete an account, it could take days, it might never be fulfilled. So what we have is that we have some kind of an organizational unit, which is a grouping of accounts. Every time we want to delete an account, we actually move that account to this organizational unit. It's like the Reaper one, and it's not active anymore. And it's not perfect, but it works well enough for us. So another interesting thing we found is that API gateway is actually quite expensive. You're going to see many articles online talking about how it's an interesting product, but it's not great. My own experience with AWS is that unless you really need to do something about the cost right now, wait for a little more, talk to your account manager. I don't know how Google and Microsoft would work on this, but talk to your account manager, see if there's any kind of price drop coming. We didn't have this with API gateway when I was at Meetup, but one thing that happened was that, well, I was mentioning that we moved some of the systems to Fargate. Fargate was very expensive. We just had no option. We knew that we were going to be we were going to increase our usage a lot, our bill a lot by using that. It turns out that I think 1 week maybe before we moved some of our systems to Fargate, Amazon just slashed the price in half, just like, because I don't know, that's kind of the Amazon policy. And that worked well, so we could actually keep using Fargate because it was OK. I don't know if that's going to happen to API Gateway. I haven't seen massive price drops there. But one of the reasons I wasn't worried about this is because what API Gateway does is actually not a lot for us. If that become a problem, I could actually just get a team on the side and create some load balancing structure that would replace that. It would be a bit ad hoc and not invented here-ish, but we could do that. That was an option for us. And this is the thing that I still am a grumpy old man when it comes to serverless architectures. There's a lot of people who tell you that Amazon provides you with everything, and it's all going to be awesome. At Meetup, we went full on Amazon. Meetup still runs some stuff on Google Cloud, but it's moving to AWS. We had only CloudFormation. We didn't even use Terraform because we wanted to make sure that we're using the right tools that our AWS people could help us with. We did everything the Amazon way, and I still had about 10% of the engineering team, the engineering organization, working on tooling. There's a lot of loose ends, things that don't talk to each other. You can clearly see that at AWS, they have many different teams, and they kind of hate each other because this feature is available there, but not integrated with this other thing. Why? This happens a lot, and you need to be ready for that. But I think ultimately, one interesting question is that, again, I was talking about serverless, microservice, blah, blah, blah. Is this really serverless? Is this what the future looks like? Because it looks very similar to what we do now. It's just like, are you sure? Well, my point is that I don't actually care, first, because that was one way we managed to get from one point to the other. But more important to me, this is also something that I tend to use as a saying I tend to repeat a lot, which is you don't move from 2 out of 10 to 10 out of 10 in one jump. I think some of the mistakes we've made in the past was exactly trying to do that, moving from a legacy application that was big and complicated and, again, 16 years old, to the bleeding edge of serverless computing with asynchronous workflows using Kafka and God knows what. And this is too much of a jump. The gap's too wide. We need to go, inch by inch and try to get somewhere. And this is an approach where I can hire somebody who has experience on microservices, and they kind of immediately understand what's going on, as opposed to what we had before that was very complicated. Now, does that mean that CQRS, event sourcing, blah, 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 don't work? Like, I'm never going to say this. Well, I don't know about never. I'm not saying this right now. But it's just because I never actually worked in a project that did this in the right way, whatever you want it to be. So I'm sure it can work well. I haven't seen it working so far. But going back to the whole, OK, you're coming from a traditional microservices background to the Lambda kind of approach. One interesting thing is that what does that mean? Like, what's the future like? And not being cynical at all, I actually think that serverless definitely is the future. As I mentioned, I used to work for a company called Buoyant. I think, is Oliver here? No, I think he's giving Oliver Gold's going to give a talk today. We have given a talk about some of the work we did there. They're still there. And there's amazing pieces of technology that are being built on the platform around Kubernetes mostly and things like this. The moment where I saw how easy it is for an engineer fresh in the company to deploy things using serverless, I said, like, OK, there's definitely something here. There's a future there. To be honest, I think it's just like AWS is pretty bad at tooling. I've worked for a few years at DigitalOcean here in New York City, which is a company that kind of, the main thing they do is to fix the user experience things that Amazon cannot fix. So I'm familiar with some of the challenges there. But once they get this through, I really legit think this is kind of the right way to go. All right, so this is the story I had to tell. I don't know if I have some time, because my clock's not working. Do you have time for questions? Yeah.
Do you have questions? No, here in front.
Thanks for the talk. On your last slide, you mentioned that serverless looks like the future, but it's not there. Can you give a list of features that you think are currently missing?
That's interesting. I don't know if there would be features per se, because I think the building blocks are there. Is how to get these things to talk to each other. Like, we have various different components that work great in isolation. And I was mentioning that we have 10% of my team working on tooling. We are not actually writing any software, any actual software. We're just linking things together, making something that will spit out a CloudFormation template that wires this thing with that thing over there. So I don't know if there's a particular feature that I'm missing, as much as just the workflow nature of things, which I believe the cloud providers are going to get better at, and some companies offer some alternatives on top.
Hello, thank you for your talk. So on the slide where you showed how you use an API gateway to essentially gate serverless functions, there was one place where you had a call from a gateway to, yes, that one, to an actual function. Can you kind of elaborate on when it makes sense to do that and when it makes sense to always go through the gateway?
So you talk about the green line?
Yes.
Yeah. So I have two answers to this question. One is that that's actually a mistake on the slide. The second one, though, is that one thing that I've seen happening in services, it mostly happens at the edge, but it happens sometimes downstream as well, is that you need the API gateway to do some form of authorization, authentication, something like this. Usually, I mean, it wouldn't be so much of a big jump from one system to the other, but it might be something like this. So it's funny, because I haven't mentioned this presentation, but I used to believe in really dumb pipes. And now I'm becoming more and more a believer of the pipe should be smart enough, and that including the API gateway piece of infrastructure. Again, rate limiting, authentication, authorization, various other things that you might need to do from that layer. But that one's totally a mistake.
Do we have another question?
Oh, it's Dan.
Great talk, Phil. Always thought-provoking. You mentioned just briefly about service meshes. I wonder, how does that fit into this kind of landscape here? Would the service mesh be east-west and the API gateway north-south?
That's a great question. So the only way I've been thinking about this right now is not, I wasn't actually, service mesh wasn't the problem I was thinking about, but I think it's the same. I was sitting down with somebody from one of the monitoring providers who was trying to sell us some shit. And we already had some of them, so just like, negotiating contracts and things like this. And I mentioned, oh, by the way, we have decided we're going to invest more in serverless. So if I go with you, because I'm signing like a 2-year contract right now, what does that mean? And the approach, the response was kind of iffy. Eventually, they got me to talk to the CTO for the company. And it turns out that all they could do was to read the Amazon logs and plot them. So extrapolating from this to your question, it's like this ecosystem is so closed up that I have no idea if anybody is going to be able to offer something at the service mesh level or any of these things. It worries me a lot because I've been an Amazon customer for many years. SoundCloud was the second largest AWS account in Europe. And I know that AWS is great at some things, but I don't like the way they develop software. I don't want them telling me how to develop software. I trust other folks to do that, not them. So yeah, I'm worried about this. But I don't know how it's going to pan out.
Thanks for your talk. So you've got a bunch of lines between Lambdas. And I'm wondering, my limited experience so far is that that's problematic, and we still end up doing it sometimes. But we're using a lot of step functions and queues and publishing topics and reading them and so forth. Can you talk about your experiences there?
So I tried to simplify a little bit this diagram, but it's funny because when I was preparing this, I thought that it would also not super match the quote I had from Chris there, because he's talking about exactly what he's talking about, many different step functions, buckets, whatever it is. In my experience, that's kind of what you ended up using to communicate these things. And you're right, like if a Lambda is fanning out too much, there's something iffy. I'm not going to call it wrong. It's something iffy that probably should be revisited. One thing I found in this kind of more actual serverless architecture using different objects or resource types is that unless you apply this rule of tying them all together with something, we could do tags, but we use accounts specifically, you are going to have a lot of trouble trying to figure out what's used by what and what's going on. We have a lot of interfaces that are just databases that get exposed to other services. And not being an actual published interface, as I was saying, creates a lot of trouble. So yeah, that's kind of how we build it with the step functions and various other objects and things. I actually don't like step functions that much, to be honest, but buckets and DynamoDB tables all over the place. And also the Kafka thing from Amazon. I forget the name now. But yeah, I agree. If you have too many fanning out from one function, probably your function is not 200 lines of code.
OK, great. I guess we have time for one short question.
Oh, she's good.
Hey, thanks for the speech. I wanted to ask, in terms of your architecture using multiple AWS accounts, wasn't clear to me what's the benefit in doing that, and also in terms of your deployment, like how's that done if you have multiple accounts? Like how do you get around that kind of dynamic account ID type thing?
So one interesting, the abstract benefit is that you need to group your resources by something, right? Usually people do by team or by environment. We decided to group them by service. We could use tags for that, but we figured out that one interesting boundary between services was going to be accounts, because that you have to explicitly jump from one to the other. It's a bit safer in our experience. One challenge we had at Meetup was that originally we had one account for everybody, all environments, and everybody had access to it. And we figured out that people were really afraid of doing anything in production because any wrong thing they've done could impact the whole company. So containing it further and further was going to be an option we followed, to a point that we decided that actually the unit was going to be the service itself. Again, it's kind of arbitrary. It could be anything. It could be just tags and things like this. I forgot the second half of your question. Oh, yeah. We have a little bit of a complicated network architecture at Meetup because of the legacy account, the things need to talk to, because the monolith's still there. But they usually for deploy, you do an assume role, whatever the primitive is called, and you deploy to that account. Engineers have access directly to other accounts, because our main thing is not that people cannot access the other accounts. They need to say, I am going to use the user service account now, as opposed to just apply something to a generic kind of coarse-grained account. Big caveat, a lot of the tooling I was mentioning about is around this. We have a lot of tooling to create accounts, delete accounts, and jump between accounts as people jump between services. It's kind of the working context or the workspace you're working with.
OK, so thank you so much, Phil, for your fantastic talk.
Thank you.